discussion, we will talk about homogeneous functions. Okay, so to start our discussion, I will give you a formal definition of homogeneity. Okay, and the formal definition, so to say, so there's a formal definition. It says in the formal definition that the function f of xy is said to be homogeneous okay, of degree n, okay, in x and y, if and only if. So there's a certain restriction, if and only if. If and only if it follows this formula, so to say, or this definition. If I will get the function of, let's say, kx, ky, so meaning to say I will substitute my x with kx and I will substitute my y with ky, I should get k raised to n multiplied by f of xy, okay, where n is the degree of my function. Okay, so let's go ahead and answer some exercises and tell whether it is a homogeneous function and state the degree of that function. Okay, so let's say number 1. Number 1, I have x squared minus 2xy minus y squared. Is this a homogeneous function? So this is my function of xy. Okay? So if I will solve, I will get the function of kx, ky. So meaning to say I will substitute, again, I will substitute kx to all the x. I will substitute ky to all the y's. Okay? So to do that, I will now have kx squared minus 2 times kx minus times ky minus ky squared. Okay? So I will now have k squared x squared minus 2 k squared xy minus k squared y squared. And as you can see here, I can factor out k squared because k squared is in all the terms of my function. Then I will have k squared times the quantity x squared minus 2xy minus y squared. So as you can see here, what do we now have? No, I have this x squared minus 2xy, and that is my function of xy, correct? And I was able to factor out k squared. No? So I already satisfied the definition that a function is said to be homogeneous of degree n if and only if this definition is satisfied. So, meaning to say, the answer for number 1 is yes, it is homogeneous and the degree of the function is equal to 2. Let's go to our next example. Example number 2. Let's say I have x cubed minus 4x squared plus y cubed. Is this a homogeneous function? So, this is my f of xy. I will obtain f of kx, ky, and it will now be kx cubed, quantity kx cubed, 4 times quantity kx squared plus quantity ky cubed. Okay? So I now have k cubed x cubed minus 4 k squared x squared plus k cubed y cubed. Okay? I can factor out k squared. Huh? K squared, that's the common factor. So I have k x cubed minus 4 x squared plus k y cubed. Okay, so the question is, did it satisfy the definition? So the simple answer is no. Okay, it is not homogeneous. Okay, because it did not satisfy our definition of homogeneity. So problem number 3. So let's say I have x cubed e raised to x over y minus 4y squared times the square root of x squared plus y squared. So here, this is our function of xy. Okay, so I will get the function of kx ky from our function of xy. So x cubed, let's do some shortcuts, no? Would be k cubed x cubed minus e raised to ky over kx minus 4 k squared y squared. So everybody understand that, right? X over y. Okay, so this should be x over y. Kx over ky. Okay, and then this will be, okay, yes, thank you then. This will now be, x squared will now be k squared x squared plus k squared y squared. Okay, so yung k dito, k will cancel out. Okay, and then here it will be 4k squared y squared square root of times the square root of k squared is common, so we can factor it out, x squared plus y squared, and then the square root of k squared is simply k, right? That will be k, and it will be multiplied to k squared here. So it will be 4k cubed times y squared times the square root of x squared plus y squared. So our function is now k cubed x cubed minus e raised to x over y. Okay? So, since so ito nalagawa ko I put this subtraction, but that's multiplication, that's multiplication. Okay, so I can now factor out k cubed. Okay, and I will have x cubed e raised to x over y minus 4y squared times a quantity x squared plus y squared, and therefore satisfying the definition of homogeneity. So yes, the answer, yes, it is homogeneous, and the degree is equal to 3. Okay?